Hi everyone, this is question number 29 in chapter 2. So we have to find the coordinates of the turning point for each of the following curves, okay? So this is the second application of the differentiation, okay? Now we have A, B, C. So for each of these parts, we have to find the turning point and hence determine the nature of each turning point. That means we have to decide whether it is minimum, maximum, or is it an inflection point with two different methods. So we have to try two different methods. One is the tangent sketching method. Another one is the second order derivative method. Okay, this is through sketching and this is through the calculation. All right, so let's just find the turning point, determine the nature with two different methods. Yeah, so let's look at A first. So in order to find the turning point, we have to know that at the turning point, the dy dx equals to 0. Okay, so for part A, at turning point, okay, at turning point, we know that dy dx equals to 0. So how do we differentiate dy dx? So that will be 10x minus 2 equals to 0. Therefore, x will equals to 2 over 10. That is 1 over 5. So since we need to find the coordinates, once we got the x value, we need to find the y. Therefore, substitute x value into the function of y. So 1 over 5 squared minus 2 times 1 over 5 and then plus 1. Okay, this one we calculate through the using the calculator. Okay, we shall get the coordinates of y 4 over 5. Okay, therefore the turning point will be, okay, make the conclusion. Turning point. Okay, write the coordinates 1 over 5, 4 over 5. Okay, now next we have to determine the nature. So how do we determine the nature? So first method, we use the tangent sketching method. So to use the tangent sketching method, there are a few things that we have to put in. We have to test the points, okay, before and after the turning point. Okay, so what do we do is we want to test the x, and then we want to test the gradient before and after. Okay, then after that we have to sketch the graph of the tangent. Okay, sketch of tangent. Okay, and finally, we combine the different tangent to sketch the curve, sketch of the graph, sketch of graph. Okay, so let's do this part. So for each point, we put down 1 over 5. We have to put the point before and after. Okay, the nearer the possible, okay? The nearer the better. So 1 over 5, after that should be, we shall take 2 over 5. And then next we put 0. Now the dy dx for 1 over 5 is definitely 0, otherwise we can't find the coordinates for x. And then the sketch of tangent, when it is 0, the gradient is 0, then it's a flat line. So let's substitute the 0 into the dy dx. So the dy dx is this, okay? So 10x minus 2, when I substitute 0 in, I got a negative 2 value. And then for when I substitute 2 over 5 in here, so 2 over 5, we have 4 minus 2. So we have the positive gradient here. So when it is negative gradient, the tangent will going downhill. When we have the positive value for the gradient, then the line is going uphill. So combine these two, we have the graph that goes like this, because at the turning point, it's like this. This is how the tangent look like. So from here, we know that it's a smiling graph, okay? Therefore, we can make the conclusion that 1 over 5 and 4 over 5 is the minimum point. Okay, write in full then. Minimum point. All right, now second method, we use the second order of derivative. If dy dx is 10x minus 2, therefore d2y, differentiate the second time, we will get 10. Isn't it? This is positive. Okay, greater than 0. That means our gradient keep increasing from negative to 0 to positive. Or you can actually equalize it with the a of our quadratic function. So when a is positive, we have a smiling face graph. Therefore, we have the minimum point. Then we can make the conclusion that 1/5, 4/5 is minimum point. Okay, that's it for the part A. All right, now let's look at part B. So for part B, we have to find the dy dx first. So when y equals to x squared over x plus 1, all right, so there's a constraint here. Our x can never be -1, yeah? In order for this function to exist, the x can never be -1 here. So let's differentiate it. So dy by dx will be stay v, so x plus 1, differentiate the u is 2x, minus stay u, okay, and then differentiate the v, that is 1, and over x plus 1 squared. Simplify it, so we have 2x squared plus 2x minus x squared over x plus 1 squared. So over here, let's simplify the fraction. So we have x squared plus 2x over x plus 1 squared. And we know that at turning point, our gradient is 0. So dy by dx equals to 0. So let's differentiate this. We already differentiated, so let's just use that. So we have x bracket x plus 2 over x plus 1 squared equals to 0. Okay, we know that x plus 1 can never be 0. Otherwise, this fraction doesn't exist. Yeah? And therefore, the one that contributes to the 0 must be x bracket x plus 2. Therefore, we have x equals to 0 or x equals to -2. So with this, we substitute into our function y. So y will equals to 0 squared over 0 plus 1. So it's 0. Or y equals to -2 squared over -2 plus 1. So we will get -4. So the coordinates, our turning points, the turning points are 0, 0, and -2, -4. So now we got to test the nature of these two turning points. So the first method will be the tangent sketching method. Okay, let's do that. All right, the first method. Since I got 2 points, therefore I shall, okay, in the table, I need to have, for every point, I need three to test 3 coordinates. Okay, actually just test the 2 before and after. So let's put like this. So this will be the x, and this one will be the value of dy by dx. So our point is -2 and then 0. All right, so we test the point before and after. So -2 before -3, then after is -1. But remember, in this function, x can never be -1, so we cannot choose that. So we shall choose -1.5. Okay, 0. Before 0 is -1. No, the nearest one. -1 cannot, it doesn't work. So we shall take -0.5. Okay. And then after the 0, we just choose 1. All right, so after dy dx, now to get x coordinate -2 and 0, the dy dx is 0. Therefore, the sketch of tangent will be a horizontal line, so flat like this. And after that, we combine the tangent before and after so that we can sketch of graph. Okay, so with this, we need the calculator to help us. Now we can just key in the function of dy dx because we have to keep using dy dx to calculate the value when x is -3, -1.5, -0.5, and 1. So let's just key in this formula. So we have to call the function of the variable here, x, right? So let's call that out, bracket alpha x squared, and then plus 2x, yeah? So gotta press alpha, close bracket, and then fraction, and then x plus 1. So alpha x plus 1, and then we gotta square the whole thing and send into the calculator. So what is the x value that we need to put in? The first value I want to put in is -3. Okay, we got 3/4. It's a positive value, 3/4. When it is positive, the sketch of tangent is going uphill. Then after that, -1.5. So what is the x? -1.5. -3. So let's put -3 here. So going downhill. So for this part, the graph that form look like this. Okay, it's a set phase graph. That means we got a maximum point. So over here, we can make a conclusion. -2, -4 is a maximum point. All right. So if this is maximum, the other one must be minimum. But anyway, we've got to show. So key in the x value again, -0.5, -0.5. So we got -3 here. Going downhill, this one must be going uphill. Okay, so what is the 1? The value when x is 1, that is 3/4. 3/4. So over here, we're going down, flat, and going up. So that will be the smiling face graph. So for this point, 0, 0 is a minimum point. So this is the method of sketch of tangent. The second method is second order of derivative. That means from dy dx, okay, which is x squared plus 2x over x plus 1 squared. So we have to differentiate another time. Okay, so again, quotient rule. So we have x plus 1 squared, stay v, do u, differentiate the u. So we have 2x plus 2 minus, remain the u, x squared plus 2x, differentiate the v. So do outside and followed by do inside. And then over the square of v, so x plus 1, and then we square the square, so to the power of 4. Now in this case, we can simplify or we can choose not to simplify, just substitute directly. So if we want to simplify, also can. Let's identify the common terms, but I don't think we need to. We just substitute the value in. So when x equals to 0, the second order of derivative will give us the value of 0 plus 1 squared, 0 plus 2, and then minus 0 plus 2 times 0 is still 0, and then times 2, and then 0 plus 1 over 0 plus 1 raised up to the power of 4. Okay, so for this one, 0 plus 1 squared, we have 1. 1 times with 0 plus 2 is 2. And then this whole thing is 0. 0 times anything is also 0, maintain as 0, over 1. So the answer here is 2. So isn't it, it's positive, greater than 0? Greater than 0 means it will keep increasing. The value of gradient keep increasing from negative to 0 to positive. Or you can equalize it with the coefficient for x squared in the quadratic function. So when a is positive, we have a smiling face graph. All right, therefore, the 0, 0 is a minimum point. Okay, so likewise, when x equals to -2, the second order of derivative will be, put the -2 in the into this. So -2 plus 1 squared. So -2 plus 2 minus -2 squared. So we have 4 plus 2 times -2 minus 4. All right, and then 2 times -2 plus 1 over -2 plus 1 and raise up to the power of 4. Okay, so over here, -2, oh sorry, 2 times -2 is -4. So over here we have -2 plus 1, -1 squared, that is 1. And then -4 plus 2, we got -2. And then -4 minus 4 is 0. 0 multiply anything is still 0. Over -1 raised up to the power of 4, we got +1. So we got -2 as our answer. Isn't it? This one is less than 0. That means it's keep reducing from a big value to 0 to a small value of gradient. Or when we equalize it with the coefficient x squared and a quadratic function, if our a is negative, so we got a set phase graph, therefore the point is maximum. So -2, -4 is a maximum point. Okay, so this is how we determine the nature of the graph using the second order derivative. Now let us look at part C. So for part C, y equals to 7 minus x cubed. So find dy dx first, the gradient function. So we have -3x squared. Okay, so at turning point, our gradient function dy dx will equals to 0. So -3x squared equals to 0. So x must be equals to 0. And if we substitute x equals to 0 into our function y, so 7 minus 0 cubed, so we have 7. So the turning point is 0, 7. Now, next, we got to test the nature of this turning point. So first, the tangent sketching method. So let's just draw the table. This is x, so we have to test a point before and after the turning point. So 0, and before will be -1, after we shall take 1. So let's check the dy dx value. So dy dx is here. So when it is 0, it's 0. Okay, when it is -1, we got -3. When we have 1, so put 1 square times -3, we have -3. So our graph will be, this is sketch of tangent. So our tangent is going downhill, then 0, and this one going downhill again. Okay, what kind of graph is this? So sketch of graph. So it looks like this. This is a cubic graph anyway. So you will have something that goes like this. So when you see this, that means the turning point here is neither maximum nor minimum. The 0, 7 is the point of inflection. Point of inflection. Okay? In the term of bahasa is titik lengkok balas. Okay, it's supposed to change direction, but it continue. The gradient continue to be negative. That is the first method. What about if I use the second order derivative? What will we get? Okay, so part 2. Now we know that dy dx is negative 3x squared. So if I continue to differentiate one more time, I will have negative 6x. So when x equals to 0, my second order of derivative, it is also 0. So when your dy dx is 0 and second order is also equals to 0, then we can make the conclusion that 0, 7 is a point of inflection. Point of inflection. Or titik lengkuk balas. Okay, so that's it for question number 29.